Hey guys, it's also more leetcode today. Today we'll be solving interleaving string. So this is a really not really a simple problem, I would say, but after you understand it, it's not really that difficult as well. So what we have been asked to do is like we'll be given three strings s1, s2, and s3, and the thing that they're doing is they're making some partitions from s1, so some partitions from s2, and then combining those partitions to form s3, right? And these partitions are not really made using some rules. They can be randomly generated. So basically we'll generate some substrings of s1, we'll take some substrings of s2, and we'll combine them to form s3. So in this case you see they're taking two a's to make these two, then they have dbb from here to make dbb, right? Then they have the c as well to make they took the c as well to make this. Then they have b c from here, right? Then they are taking a from here and c from here to make this ac last part, right? So this can be done. So then they're returning true. Again, if you check this one, they are having aa, then this a is from here, then they have dbb, we have dbb, then they're taking another b from here, right? And after that they have accc, but you do not have any a over here, right? Both have c's. You cannot do it in any other way so that you get a acc over here. So that here will return this false. And again they have like clarified this, that if we have empty strings, then it will also be true, right? So even this is fine. So how do you approach it again? So this is again like it's you can do one thing though, which is you can generate all substrings of s1 and s2, and then you can check for which one you are getting s3. If you're getting s3 in some substring, then it's definitely possible, otherwise it's not. So it would be like a decision tree, right? So s1 you'll make substrings from s1, you'll have a lot of substrings. How many will have? You will have 2 power of n, right? So 2 power of n substrings from s1, this will be 2 power of n. And then you'll have for s2 you'll have similar 2 power m, where n and m are sizes of the strings, right? So basically you have to combine these two, and you'll have a solution of 2 power of n plus m, right, to get the s3. Now after you get s3, if you get it, you will return true, otherwise you'll return false. So this will be a 2 power of n plus m solution, but this is again not really efficient, right? So what we have to do is here we have to like somehow reduce the time complexity. Now you know one thing, which is dp, which will reduce the time complexity to a lot of extent. So here again we are using recursion itself, right? So we are making use of recursion and finding out each substring from here. So instead of doing that, what will we can just notice something simple. Okay, so let's consider this way. So I'll have empty string, so I'll make some a table sort of thing. So I'll make this, let's say I'll take this example. I'm taking this example. So I'll have a b c c, okay, and I have here d b b c a, right? Now what I can do is, see, so I'll take each index from here, one from here, one from here, that is, right? And I'll compare it with this one, right? Now if so there can be two, or yeah, there can be two cases, or actually three, but I'll consider two for now. So let's say the I is the one from s1, okay, this is I, this is j. For this I'm taking j, for this I'm taking key to keep track of the indices, right? So now there can be two cases initially. One is this k that we have, right? The index at k for s3 is equal to the index at I plus j minus 1, sorry, plus 1, not minus 1, this index. These two are like for any ij I can get this basically, right? So if this is possible, I can definitely say that this might return true. This might return true. Why? Because it can return false as well in some cases. But if this is not possible, then I can definitely make it false, right? So this is one thing that I can notice. The one more thing that I can notice is, if let's say this is satisfied, then we need to check two things. Firstly, if the current one that we are adding, that is, let's say we are adding I, right? Let's say we are adding from s1. So the current one that we are adding, if that is making things equal, okay, so if that is making things equal, we have to check for the previous one, right? So you have to check for I minus 1 as well. So if I minus 1 is like up till I minus 1 it's the same, then it will be a true, otherwise it will be a false. Same for this, like if you're adding j, then we have to check for j minus 1, right? Something like that. So like that, if you want to fill it up, the first layer we will have like empty strings. This would be true anyways, right? Then again empty string and a, you have to check from here. So this is a, right? And adding a empty string before that, okay, and this a is there, so again it would be true, okay. Then we have what, again we have a, this would also be, so basically all these would be true, right? But it might not be true in all cases, so we'll see when it might not be true. So again you have d, right? And okay, let me retrace this one. So yeah, you have empty string, this is true. Now next you have this, so now I is 1, j is 0, and that is 1. So you have like, I mean k is 0 as well. So is this equal to this I plus j plus 1, which is what, it is 2, right? So k plus 1, which is 3. So d, sorry, what am I saying? Yeah, so we have k is I plus j plus 1, right? So I plus j, I is 1, j is 0, and plus 1 if you do, it's 2, right? So k of 2 second, so this one, right? This one, is it equal to this? No, right? It would be false. Same again, if you just go on, all these would be false, right? All these would be false similarly, right? All of these I'll get false, right? Next, if you check for this d, so if you check for this d, I is 1, j is 0 in here, and if you do it plus 1, then again d, and here you have d, so this is true. Okay, now why is this true? Because the previous one is also true. Okay, and we are adding the jth part basically, right? Here again, if you check this thing, so this is what, I and j are both 1, and you have plus 1, which is making it 3. So now we are adding a, right? So in this case we are adding a, and it is 3, so this is d, I mean this is b, so it's false, right? So this is how you can build the whole thing. Now this, if you do, if you I won't continue it because it would be a lot messy over here. So if you continue it, we'll be able to notice that it'll have like all the things over here, right? So yeah, so once you do this, you'll be able to get something like this. Okay, I just went on and did the whole thing. So once you get this, now you notice, so for this true, we're checking all the other like above conditions, right? So for this true, we are checking this and this, right? For this, we are checking these and this. So this is what we are doing. So instead of doing this, what you can do, but not like this is, again, this is fine, right? This will give you a O of m plus n time, and sorry, what am I saying? So it will take O of mn time, and O of mn for space as well, right? So this would be both time and space, right, in this approach. Okay, but again you can make this even further optimized. And the time would be the same, right? The time would be this, but the space you can make it O of n actually, or actually yeah, O of m, if you can, m is the length of the second string, you can make it like this. Now how do you do it? So you have to just notice one small like minute thing over here. So if you check any row, let's say I take this row, okay. So for this row, what am I doing is, I'm like in this row I is 0, right? So I'll like compute all the columns, okay. Now in this column, again j is 0, so I'll compute all these values, right? But if you consider this one, okay, this is what, this is being computed from these conditions and these two, right? Again this one is being computed from these two and the conditions that we have. So we can check, like the conditions will be there anyways, but for these values, this is actually where we can compare these two, right? And the previous value that will be storing here. So if I just convert it into a 1D matrix, I mean the 1D vector, okay. So what we can do is, we can do it this way. We'll be having these. Now it would be 3 3 6. So yeah, so initially I'll have all as this as true and rest as false, right? So when I come to the when I come for the next value, what I'll see is this is already a false, right? So let's consider this one. I'll not write the whole thing. So let's consider this one for this one. So when we come here, so these would be false, right? So this is what we have after iteration of this thing. So after doing this, before we go to here, we have this value, right? So these two will be true. Let me just make this true, and I'll just cut it out and make it true. That would be better. So yeah, now this is true. Now when you come to this, all you need to do is you need to check this value, check this value and the conditions that you have, and then update this value, right? So that way you can actually use a 1D array and do the entire thing. This will optimize it a bit further. Like it will just need a bit less of space. That's it, right? And yeah, so after this all you need to do is to return this ending thing. So this thing is all you need to return, right? So yeah, that is it for the explanation part. Let's just see the time complexity and space complexity again. So again, time complexity is m o of mn, right? Because we are iterating to each and every row and column, and space is again o of m, as I mentioned. So m is your like length of the second string, this one. So yeah, with that done, let's now jump onto the code and see how we'll be coding this up. So this explanation is not really that good. It's a lot messy, but it would be a lot clearer in the code. Right. So first thing that we always like to do is take the value, like the length of the strings, right? So, and once I've taken the length, I can actually go on and go on with my algorithm. And yeah, with that I've taken the length. Now let's go on and do the algorithm. But before I do it, there is a simple edge case that we need to check, which is this one. So if n plus m is not equals to k, right? So in that case, what? The string lengths do not even match up. So we can directly return false over there. We don't even need to do anything because this we cannot detect afterwards. That's where. So now let me just make a vector of Boolean type, and what this vector will store is the values that we'll be having. So I'll make it in the of the size of the second string plus one, just to have one more space for the empty string part. And yeah, with that we have this vector. Now what we need to do is we need to iterate through all the like rows and columns, that is the s1 and s2, and we need to basically fix the sizes, I mean fix the vectors values, right? So I'll do that now. This is the first one that we will be iterating for, right? Well, I'll just define some stuff over here now before I do this, because we'll be using a lot of conditions, so it's better to define it here. So the first thing that we need to define is the first condition, which is let's name it C1. Okay, and the condition is basically that this basically it's this thing. So if the jth element of this one, the second string, so this is equal to the like this is false, right? I mean sorry, this is true, and the condition that we had, that the string values will be equal, the new string value and the kth value will be equal. That is the condition that we'll be adding over here. All right, so I'll add dp at j, and the dp at j is the boolean value, and s1 sorry, yeah, so s1 at I minus 1, this is the first string, right? Is s3 and j plus I minus 1, right? This is what we have for the first condition. Now the second condition will be exactly similar, so I'll just copy paste, and what it will do is it will check the last value, not the same value. This would be for g, right? This will be for s2 as well. With that we have the conditions in place, right? Now all we need to do is for each value we need to iterate. This is just to like reduce our code a bit, that's it. Now we'll set the value at j of the dp vector, right? And what will the value? So initially I'll first check for I0 and J0, right? So if these are true, if both I and J are 0, in that case I'll set it to true, right? And otherwise I'll just check if I is 0. Okay, if I is 0, in that case I need to run the condition 2, so that would be C2, right? Otherwise I'll check if j is 0, right? This is like, again, I'm just reducing the code, nothing else. This is like, you can even write a if else condition for this. Okay, so if j is 0, then I'll be doing the first condition, which is this, right? And once that is done, and let's say both are non-zero, then I'll be taking all of these two conditions, right? Which, like, even if one of them is true, I'll be having it as true as well. So I'll have this. So with that, we have everything ready. Now I'll just return the dp at n. That is a really simple thing to do, all right? And I actually did some, okay, the typo over here. Yeah, that was really small typo. And yeah, as you can see, it's pretty efficient. So yeah, that's it for today, guys. Thanks a lot for watching. If it helped, do like and subscribe. And yeah, that's it. Bye, guys.